Hi, this is Robert Greer. This is CSC 588 Milestone 2. I'll start by playing all the demos and reviewing their output, and then I'll go into the code and architecture. So I'll build and start the demo. You can start the first demo by pressing 1. It does a blocking load of all the resources. Then it starts playing the fiddle. Now we'll do the panning. Panning the other way. Then volume up. And volume down. Now we'll do the playlist with 2 channels. And we'll print out the time it's been playing. Cut out the left side of the playlist. And then stop it all together. And then the multiple instances of the same sound. And that's the first demo. Press Q to quit and clean up after that demo. And then we'll start demo 2. So blocking load of Seinfeld. And on a single playlist, it'll play back the sequence of assets in the Seinfeld song. And it'll periodically pan the audio. And you can see the XAO2 callback is what's initiating the stitching. And then the entire playlist completes. We can quit the demo with Q, clean up, and then we'll start demo 3 by pressing 3. And then quit with Q. So just to review what happened there, scroll up to the top, we start our first 3 sounds with 10, 50, and 150 priority. We add the next one with 50, add the next one with 75, and then we fill up the table with the 100 priority song. Then we try to add another 150, which evicts the previous 150 that was playing. And then we have a new 150 with 0 time. Then we play a 75, which evicts the 150 because it's lower priority, or technically higher priority. And then we just have 2 75s. And then we play another 75, removing the 100. And then we play another 75, which removes the highest time 75 priority, because now it's tracking by time. And then we continue. We reject the next call because its priority is 150, which is higher than all the existing ones, so it gets rejected. So at the end, this is what the table looks like. And then we kill all the sounds and clean the priority table so that it looks like this at the end. So that's the priority demo. Next, I'll start the user callback demo by pressing 4. So that ends. We clean up with Q. And we'll take a look at the output. You can see on the user thread, we have these user callbacks triggering whenever the sounds end. So the user callback first is dial, it's panned to the left, and it's played for about 1 second. Then we have sequence was panned to the left, played for about 5.3 seconds. And then we have donkey, which was panned to the right. It was 5.38 seconds about, and it was also started later on a timer, so it ended third. And then lastly, we had the long one, which was Moon Patrol, which was panned to the right, and it had duration about 25 seconds. So those are the user callbacks on the user thread. Next, I'll start the last demo, which is the async loading. So you start that with 5. So we're doing an async load for Beethoven, was requested, but we're already playing Electro and Alert because they're ready in the wavetable, and Beethoven is pending in the wavetable. Beethoven has loaded, it's ready in the wavetable, and on the user thread we react to that by saying something was loaded Beethoven, and we start playing it. And that demo ends, and we automatically remove the assets, and then we can clean up with Q. And then we can exit the program with escape, and it closes all the threads, and memory tracking passed. So next I'll show the demo code to show what it would look like from a user's perspective. So first you start by loading assets with an ID and a file name. Then you can attach those assets to a sequence, which will play stitched together. In this case, it's just one. Then you attach the sequences to a playlist. Then you can create sound instances from a playlist, and you can create multiple sounds from one playlist ID. And then once it's all loaded, we can start doing the steps of the demo. So we play back the sounds by setting properties and playing them. I do the interpolation on a separate thread using a helper class. I also do the interpolation of the volume using a delta value by getting the volume, adding a delta, and then setting it again. Then what I do is the dual channel song by playing primary and secondary with different properties. I can get the time playing and print it out. I can pause one of the channels and keep the other one going, then stop the sound altogether, and then play the separate instances of the same sound on top of each other. For the next demo, Seinfeld, I set it up with a bunch of audio assets, but they're all attached to the same sequence, Seinfeld. So that way I can create one sound that'll play them all stitched together just as a single sound, and I can set the panning volume all as one sound to make that work. Next is demo priority. So the priority is a bunch of sounds once again, except when I play them, I pass in the parameter for priority, and that's just according to the demo, and I printed out each event, and then I stop them, kill the table, and print it out one last time. So that's priority. Next is the user callback. So same thing as before, except now I pass in a callback to play, which will execute when the stream ends on the user thread as well. So I play with the callback, and then I also play donkey and the delayed event with the callback, and then the callback's defined here, and it executes on the user thread, and it prints out the correct properties. Next for async, so once again loading the assets, except now I say that the first two are blocking explicitly, and then I say that the Beethoven is async. And I also pass in an observer callback for that, which will execute once the file is loaded. That just says start Beethoven and starts playing Beethoven once it's loaded, and without it being interrupting the other thread. So then once this demo ends, it will unload the assets so that I'm not filling up the wavetable from demo to demo, and demo that cleaning up. Also, for each of the demos, I clean up after myself by unloading all the stuff so that I don't fill up the wavetable or the play table, and that way I can repeat the demos and have it be more easily tested. Now I'll go over things that have changed since the previous sprint. So I changed the callback for the asset command by being an individual callback per call to load audio asset instead of a general purpose callback. This made more sense because I want to have a specific behavior once Beethoven is loaded. Next, I added the user callbacks on the user thread, and the way the user callbacks work also applies to the audio asset callback. So the user callback is passed in as a optional parameter to play, and it will execute on the user thread. So I added a new thread called user thread that is basically the same as all the other ones, just looping through a set of commands, and it has its own queue as well. So the user thread is best demoed using my diagram. So the diagram here, I create a stream end callback that's passed into play. It gets sent over on the create sound command to the audio sound and stored there. Then when the on-stream end happens in the XIO2 callback, it signals to the audio sound that the stream ended, and so the audio sound sends its stream end callback through the user queue to the user thread, which gets executed as a command there. So that's how the architecture of that works. Next, for the priority. So to get the priority demo working, I added the priority table to the game sound, which is a static priority table with the mutex, and you can pass in the priority when you want to play a sound, which will check if there's an open slot. If not, it will check the table, which is sorted by both priority and by time, so that it will take up the correct slot when you want to play it, or it will reject the sound if it can't play it. Then I added the handle update as well to a shared mutex so that it can be reference counted. And so in the lock and unlock, it references or unreferences the handle. That way the handle can't be invalidated while someone's still referencing it. So that's the changes since the previous sprint. Lastly, I'll go over the architecture of the audio system just to show the highlights. So to start off, we have the game sound. This is what the user mainly interacts with to play the sound and set all the properties. It's protected by a handle, and there's several classes that are protected by handles throughout the system. And the handle just wraps the functions to make sure that the object's still valid when someone wants to use it. Then you have the Game Sound Manager, which is sort of a one-stop shop for doing audio things like loading assets, sequences, and playlists, and playing sounds. And it's a good example of how these just create commands and send them over to the audio thread to actually do that behavior. On the audio thread side, we have things organized into classes. So this is the audio asset, which represents a WAV file with the buffer and format. These are owned by a manager, and then they can be organized into sequences. So sequences are also on a manager, and they just represent a stitched together sequence of WAV files through buffer stitching that can be played, such as Seinfeld. The audio sequences are owned by playlists, which can have several sequences to play back at the same time, like the first song that plays 2 channels, and it plays those back on a list of voices. A voice is just a wrapper around an XAudio2 voice, which has a voice callback, which will initiate the stitching, as well as the stream end callback if necessary. So the playlist is owned by the audio sound, which is sort of the mirror image of the game sound, but on the audio side. So that's the hierarchy there on the audio thread. Lastly, I can go over some extra things such as the asynchronous loading. Here's the audio command for loading an asset. If it's blocking, it'll load right away. Otherwise, it delegates to the file thread, just another thread to execute that command. And then also for the user thread, when we have the user callback on stream end, we just send the callback over to the user and let it execute there. So that's a high-level overview of the engine, and thank you for watching.